Alright, today we are going to be talking about rational functions some more. Okay, and here we go. Clearing an equation of fractions. We're going to have equations today. And when you have equations, that means you have an equal sign. If you have an equal sign, you can actually clear your fractions. And I've taught you this before with problems. They just haven't been polynomials. So the step is you factor every denominator, and then you multiply both sides, which means every term on each side by the LCD. Cancel like factors, multiply the tops, multiply the bottoms, cancel where you can, and then you're done. Here we go. What I do is I make a list. Okay, I make a list where I look at all my denominators. There's a denominator of a 4, there's a denominator 3. So to clear them, I'm going to have to multiply everything by 4 and 3. So if I multiply by 4 times 3, multiply by 4 times 3, multiply by 4 times 3, you've got to do it to every term, even if it's not a fraction. Okay, then the one that matches the one on the bottom is going to die, and the rest are going to multiply. So here the 4 cancels, and I'm left with 3 times x plus 2. The second one, the 3's cancel, and I'm left with minus 4 times x minus 1. On the end, nothing cancels, so you multiply them all, 2 times 4 times 3. And then your fractions are gone. So now we can solve it like we've been solving equations since Algebra 1. Alright, so distribute, and multiply, and I get 3x plus 6 minus 4x plus 4 equals 2 times 4 is 8 times 3 is 24. Combine like terms, 3x minus 4x is negative 1x. 6 plus 4 is 10 equals 24. And solve it. Minus 10, negative 1x equals 14. Divide by negative 1, divide by negative 1, and x equals negative 14. Maybe. You've got to check your answers anytime you have fractions with variables on the bottom. Because if you have a fraction with a variable on the bottom, you run the risk of that going to 0, which makes it illegal. So if you look back at the original problem, and I look at my restrictions, I say, in other words, to get my extraneous solutions or to check to make sure that a solution works, you'd plug it back in. But that's a lot of math to do, and it's easier just to go, look, Mr. Denominator, you can never equal 0. Well, there's not even an x in it, so there's no chance. Mr. Denominator 3 may never equal 0. Well, there's no x in it, so this ain't going to happen. So there's no restrictions, which means I can keep whatever answers I get. So I got x equals negative 14. Alright, so if we solve and check this one, now here's where, guys, if you... let me see, what would be the smallest? I think 24 would be the smallest number that they all go into. Yeah, 24 would be the smallest. But a lot of people can't see that, okay? And there's nothing wrong with you. Here's what's easy to do. You might have to do a lot of reducing later, but make your list. I've got a 6, an 8, and a 4 on the bottoms of the 3 different fractions. So to clear them all, I'm going to have to multiply every term by all 3. So 6 times 8 times 4, 6 times 8 times 4, 6 times 8 times 4. Then it either dies or multiplies. The 6's cancel, so I'm going to have 32 times x plus 3. On this side, the 8's cancel, so I'm going to have 24 times 3. Here, the 4's cancel, so I'm going to have 48 times x minus 5. Alright, so now to simplify, we're going to distribute, and then solve for x. So I have 32x plus 96 equals 72 plus 48x minus 240. Okay, so now I'm going to get my x's together on the same side, and I don't want to go negative, so Oh, I can combine those two terms. 72 minus 240. So here we have 48x minus 168 equals 32x plus 96. Now I'll get my x's on the same side. And I don't want to go negative, so I'm going to move the smaller one. So I'm going to subtract 32x, which gives me 96 equals 16x minus 168. And now to get x alone, I'm going to add 168, and I get 96 plus 168 is 264 equals 16x, divide by 16, and x equals 264 divided by 16, which is 16.5. Okay, and if Math Excel wants a fraction, then hit Math, enter, enter, and that'd be 33 over 2 in fraction form. Now, you got to make sure that you can keep the answer you got. Well, looking at your denominators, does any of the denominators have an x in them? No. If there's no x in the denominator, there's no drama, which means I can keep all answers. Alright? Alright, you try this one. Come back when you're ready. And hopefully you got one. Alright, in my list, I have a 5 and a 3. So I got to multiply everything by 5 and 3. And then die or multiply. The 5's cancel. I'm left with 3 times 2x equals the 3's cancel. I'm left with 5 times x. Nothing cancels, so I multiply them all, which is 5 times 5 times 3. So distribute, distribute, and multiply. And I get 6x equals 5x plus 25 times 3 is 75. Subtract 5x, I get x equals 75. And again, no letters in the denominator, so I don't have to throw any answers out. And you try this one now. Hit pause, come back when you're ready. And hopefully you got 3. Alright, this one I'm going to show you how to do it with a smaller denominator. If I look at those, the smallest number all of them will go into is 42. Right? So I don't really need a 6 and a 7, which make 42, and a 42. If I just use 42, okay, here the 6 goes into 42 7 times, which makes 35x. Oops, this one too. Nothing dies. So, oh, yeah, it does. Yeah, nothing dies on the second one. So I multiply and I get negative 42x. The 42's cancel here, which gives me x. 7 and 42 don't cancel, but 7 goes into 42 6 times, which gives me negative 24. So now I get my x's together. Add x, I get... Wait a second, I got x's all over the place. And it doesn't matter what order you go in. So I got 35x minus 41x equals negative 24. And if I do 35 minus 41, I get negative 6x. Okay. 35x minus 42x equals x minus 24. So I got negative 6x equals negative 24. Divide by negative 6, I get x equals 4, not 3. I wonder if I did something wrong here. Let me look. If we do this long ways, and I don't use the smallest, it should not matter. 6, 42, 7, 6, 42. 42, 7, 6, 42, 7, 6, 42, 7. Sixes are gone, nothing's gone, 42's gone, 7's gone. So I'd have 42 times 7 times 5 is 1470x minus 64, sorry, 6 times 42 times 7, 1764 x equals 6 times 7 is 42x minus 4 times 6 times 42 is 1512. Alright, so let's do these two first. 1470 minus 1764, I get negative 294x equals 42x minus 1512. Subtract 42x, and I get negative 294 minus 42 is negative 336x equals negative 1512. Divide by negative 336, and I get x equals negative 1512 divided by negative 336. Oh, for crying out loud, now I got 4.5. Oh my goodness. Alright, let's start over and be really careful. Tamsin. Alright. 42 should be enough to kill everything. So if I multiply everything by 42, or put it this way, maybe do it this way. A 6 and a 7, a 6 and a 7, a 6 and a 7. And I don't need a 42 because 6 times 7 is 42. So on the first one, let's see how easy it is to make mistakes. Of course, I'm half asleep, so 6's cancel. You get 7 times 5x less. Oops, I do the middle too. Nothing cancels in the middle, so that's going to be negative 42x. Here, 6 times 7 is 42, which cancels 42, which leaves me x. And here, the 7's cancel, which would leave me negative 24. So this would be 35x minus 42x equals x minus 24. 35 minus 42 is negative 7x equals x minus 24. Minus x, there we go. Negative 8x equals negative 24. Divide by negative 8, divide by negative 8, and x equals 3. I really don't know where I screwed up. I shouldn't have erased it so I could figure it out, but yeah, it's 5 o'clock in the morning, so sorry. Alright, so how do you solve simple rational equations in one variable? We're not simplifying. How do you solve simple rational equations in one variable? Oh, well, you clear your fractions and solve. Pretty easy. Alright, so it says clearing an equation of fractions where you have actually variables in the denominator. And now you've got to factor every denominator and then write your restrictions on the domain, set each factor to 0 and solve, multiply everything through to clear your fractions, cancel, and then multiply what's left on top and bottom. So again, same process here, it's just now they're going to put variables in there. So if I make my list, my first denominator is an x, so I'm going to have to multiply everything by x to kill it, which is going to kill that x and that x. Okay, so anything that I haven't colored left, I have a 5 I need to use, and I have a 2 that I need to use. So those are all the factors that are in the denominator. You got a factor of x here and here. You got a factor of 5, and you got a factor of 2x, but that's a 2 and an x, which is 2x. So what I need to do is multiply everything through by x times 5 times 2. I'm going to rewrite my problem. So I have 1 over x equals 1 over 5 plus 3 over 2x. So what I need to do is multiply by an x, a 5, and a 2, an x, a 5, and a 2, an x, a 5, and a 2. Okay, then it either dies or it multiplies. So here the x's are going to die, and I'm left with 5 times 2 times 1 equals, here the 5's are going to die, and I'm left with 1 times x times 2. Here the 2 is going to die, and the x is going to die, and I'm left with 3 times 5. So if I clean this up, I have 10 equals 2x plus 15. Subtract 15, negative 5 equals 2x, divide by 2, x equals negative 5 halves. And as long as it's not something that I can't have in the denominator, then I can keep my answers. So check it. Go look at your restrictions. Mr. Denominator may never equal 0. Well, that's not 0, so I'm good. 5 can never equal 0. Well, that's just silly. There's no x in it, so there's no restriction. And 2x can't equal 0. Divide by 2, x can't equal 0. Well, I didn't get 0, right? So I can keep my answer. Alrighty? Alright, a little more complicated now. The trick is to factor if you can. I can't factor this guy. I can't factor this guy, but I can factor him. That's difference of squares. So that's x plus 1 times x minus 1. So if I rewrite my problem, I have 2 over x plus 1 minus 1 over x minus 1 equals 2x over x plus 1 times x minus 1. So when I go to make my list now, my first denominator is an x plus 1. So I need an x plus 1 in my list, and it will get rid of both of those. Okay, then the next thing I see is an x minus 1. So I need an x minus 1 in my list. And that will take care of every x minus 1. The only time you need more than one of anything is if your denominator has, one of your denominators has more than one of something. Alright, so that's my list. That's what I need to multiply through by. So I'm going to multiply everything through by x plus 1 times x minus 1, x plus 1 times x minus 1, x plus 1 times x minus 1. And then we cancel. So now we cancel. On the first one, the x plus 1 is going to cancel. Second one, the x minus 1s are going to cancel. And on the third one, they're both going to cancel. So if I multiply what's left, I have 2 times x minus 1 minus 1 times x plus 1 equals 2x. No more fractions. And we can solve like we were back in Algebra 1. Distribute. I get 2x minus 2 minus x minus 1 equals 2x. Combine like terms, 2x minus x. Oops. What'd I do? No, did I just erase everything? Alright, this was 2 over x plus 1, 1 over x minus 1, 2x over x plus 1, x minus 1. And in my list was an x plus 1 and an x minus 1, x plus 1, x minus 1, x plus 1, x minus 1. Alright, so now we're going to die or multiply. The x plus 1's cancel, the x minus 1's cancel, and here they both cancel. So I'm left with 2 times x minus 1 minus 1 times x plus 1 equals 2x. I'm going to distribute, oh, dang it, I'm going to distribute, I get 2x minus 2 minus x minus 1 equals 2x. Combine like terms, 2x minus x is x, negative 2 minus 1 is negative 3, equals 2x. Get x's together. I'm going to move the smaller one so I don't make negatives, and that gives me negative 3 equals x. Now, we got to go check our restrictions. I can only keep that if it doesn't make a denominator go to 0. So I say x plus 1 you may never equal 0, which says x may never equal negative 1. I didn't get negative 1, so far I can keep it. My next denominator says that x minus 1 can't equal 0, which means x can never equal positive 1, which I didn't get, so I'm good. And then if I do my third one, x squared minus 1 can never equal 0, add 1, x squared can never equal 1, square root, x can never equal plus or minus 1, which is what we already knew. Okay? And I didn't get plus or minus 1 for my answer, so it's good and I can keep it. Alright, let's look at another one. I can't factor x minus 4. It's a binomial, degree is 1, and they have nothing in common. Same reason for x plus 2 not being able to be factored. This one should be an easy factor because a is 1, so x times x. Factors of 8 that make 2 would be 2 and 4. C says, since C is negative, only the bully gets the middle and he doesn't. So, in my list, I'm going to rewrite this. So 1 over x minus 4 minus 5 over x plus 2 equals 6 over x plus 2 times x minus 4. Yes? So your first step is, again, always to factor every denominator that you can. Then make your list. My first fraction has a denominator of x minus 4, so if I put that in my list, that'll take care of them both. The next factor I see is an x plus 2, which will take care of every x plus 2 in denominators. So that's my list. So I'm going to multiply everything through by x minus 4, x plus 2, x minus 4, x plus 2, x minus 4, x plus 2. Then we're going to dire multiply. The x minus 4 cancels. I'm left with 1 times x plus 2. The x plus 2's cancel. I'm left with negative 5 times x minus 4. These both cancel, so I'm left with 6. No more fractions. Okay, so now we are going to simplify. Distribute. I have x plus 2 minus 5x plus 20 equals 6. Combine like terms, that's negative 4x, positive 22 equals 6. Now to get x alone, I'm going to subtract 22. I get negative 4x equals 6 minus 22. It's negative 16. Divide by negative 4. Divide by negative 4. X equals 4. Unless it gives me a bad solution. So I have to check. So I go to each of my denominators and say, Mr. Denominator, you may never equal 0, which says x may never equal 4. And that's what I got, so I have to throw it out. There is no solution to this problem because the answer that I get could cause one or more denominators to go to 0, and that's illegal. So this would be no solution. Alright, so you do this one. Hit pause, come back when you're ready. There we go. Sorry, I thought it froze on me. Alright, and hopefully you got 2. Alright, so if we, and again, if I read the directions, it says first, write the values that make the denominator 0. So you just go and make your list. Mr. Denominator, you may never equal 0, so x can't equal 0. Next denominator, 2x can never equal 0. Divide by 2, x can never equal 0. We got the same thing twice. And then this doesn't even have an x in it, so there's no restrictions. So I can keep my answer as long as I don't get 0, which is what that says. So now I'm going to make my list and check it twice. I'm going to find out who's naughty or nice. Just kidding. So in my list, my first denominator is an x, which will get rid of any monomial x, any factor of x. My next number is a 2, which will get rid of the 2. My next number is a 4, which will get rid of the 4. So I got to multiply everything through by x times 2 times 4. X times 2 times 4. It doesn't matter what order. X times 2 times 4. X times 2 times 4. See, and I almost forgot 2. Don't forget, you've got to do it to every term, not just the fraction terms. All right, so now die or multiply. The x's cancel, and I'm left with 2 times 4 times 7. Nothing cancels here. So I'm left with 2 times 4 times 2 times x. Here, the x cancels, and the 2 cancels, and I'm left with 4 times 5. And then here, the 4's cancel, so I'm left with 9 times x times 2. And it might not be very pretty, but the fractions are gone. So simplify. 2 times 4 times 7 is 56. Plus 2 times 4 is 8 times 2 is 16x equals 20. Plus 9 times 2 is 18x. So if I solve this, I'm going to subtract 20. And I get 36 plus 16x equals 18x. Get my x's together on the same side, so I'm going to minus 16x minus 16x. I get 36 equals 2x. Divide by 2. And x equals 18. I didn't get 0, so I can keep it. Alright, try this one. Come back when you're ready. And I hope you got 3. Alright, so first of all I'm going to factor. I can GCF by 2, which leaves x plus 1. I can GCF by 4, which leaves x plus 1. And this one is prime. So if I rewrite my problem, I have x over 2 times x plus 1 equals negative 2x over 4 times x plus 1 plus 2x minus 3 over x plus 1. So then if I make my list, I have a 2, which will take care of this. I have an x plus 1, which will take care of this, this, and this. So the only other thing that I haven't covered is that 4, so I also need a 4. And again, just 4 instead of 4 and 2 would work, but I think if people don't have to worry about the smallest, it doesn't matter. It'll all reduce down anyway in the end. So I've got to multiply everything through by a 2, an x plus 1, and a 4. A 2, an x plus 1, and a 4. A 2, an x plus 1, and a 4. Die or multiply. So here, the 2's are going to cancel. The x plus 1's going to cancel, and I'm left with 4 times x. On this side, the 4 is going to cancel, the x plus 1 is going to cancel, and I'm left with 2 times negative 2x. And here, the x plus 1 is going to cancel, so I'm left with 2 times 4 times 2x minus 3. And the fractions are gone. So if we simplify, I got 4x equals negative 4x plus, this is 8, 16x minus 24. Alright, so now if I combine like terms, I get 4x equals 12x minus 24. I got to get my x's together. So I'm going to minus 12x. I know I'm making a negative, but that's going to give me negative 8x equals negative 24. Divide by negative 8. And I get x equals 3. Maybe. You got to go back and check. If I go back to my factor, I can say 2 times x plus 1, you may never equal 0. Well, divide by 2. X plus 1, you may never equal 0. Minus 1. X may never equal negative 1, which I didn't get, so good. My next denominator, 4 times x plus 1, may never equal 0. So divide by 4, divide by 4. I get x plus 1 can never equal 0, so subtract 1, so it says x can never equal negative 1. Yeah, I got that. Okay, and then the third one said, oops, hold on. The third one says that x plus 1 can't be 0, but that's just going to give me the same thing back. Okay, so we're good. X equals 3, and I can keep that answer. Okay. All right. So you try this one now. Hit pause. Come back when you're ready. And hopefully you got 4. All right. We got to factor all these bad boys. Okay. So if I factor this, it should be an easy factor. M times M is M squared. 5 and 3 would make 2. Bully, or C says negative, so only bully gets the middle. If I rewrite this one, bino, M times M, factors of 25 that make 10 are 5 and 5. C is positive, so they both get the middle. And the third one is the exact same as the first one, so that's going to be x plus 5 times M minus 3. Sorry, I'm switching letters on me. That's an M. Okay, so if I rewrite this, I'm going to have M plus 7 over M plus 5 times M minus 3 minus 7 over M plus 5 times M plus 5 equals M minus 7 over M plus 5 times M minus 3. So if I go make my list, I need to clear an M plus 5. So I need one of those, which will kill 1 in every denominator. It won't kill both in the same denominator. It will kill 1 out of each denominator, but it won't kill 2 out of the same one, which means to kill both of them, I've got to have 2 copies. That will get rid of this one. The only thing left in my list that's not colored is the M minus 3, so I need one of those, and that'll cover both of those. So what I'm multiplying through by to clear my fractions is going to be M plus 5, M plus 5, M minus 3, M plus 5, M plus 5, M minus 3, M plus 5, M plus 5, M minus 3. Now we die or multiply. The M plus 5 is going to cancel. The M minus 3 is going to cancel, so what I'm left with is M plus 7 times M plus 5. Second fraction, the M plus 5 is going to cancel. The other M plus 5 is going to cancel, and I'm left with negative 7 times M minus 3. And on the third fraction, the M plus 5 cancels, the M minus 3 cancels, and I'm left with M minus 7 times M plus 5. Okay, and all my fractions are gone. So now it's just a matter of cleaning it up. Distribute, I get M squared plus 5M plus 7M plus 35 minus 7M plus 21 equals M squared plus 5M minus 7M minus 35. Okay, it looks bad, but it's really just now combining like terms. So let's see. On this side, I've got an M squared. I've got 5M plus 7M is 12M minus 7M, or I could just say those cancel, so I'm left with 5M. And I have 35 and 21, which is 56. On the other side, I have an M squared. 5M minus 7M is negative 2M minus 35 comes down. So now we're going to get the second degree, so I've got to get 0 on one side. So minus M squared minus M squared. Hey, looky at that, I don't have a square anymore. Now I just have 5M plus 56 equals negative 2M minus 35. So now we've gone from having to get 2 answers to only having to get 1. So now I'm going to get my M's together. So I'm going to add 2M, I get 7M plus 56 equals negative 35 minus 56 minus 56, 7M equals negative 35 minus, oops, what happened? Minus, what I do? Minus 35 minus 56 is negative 91. Divide by 7, and m equals negative 13. And I got to check my, can I keep it or not? Well, again, if you just look at your factors, I mean, if this is what's in my list, then this says m can never be negative 5, m can never be negative 5, m can never be 3. And I didn't get any of those, so my answer is good and I can keep it. All right. So what are the steps involved when solving a rational equation? Well, you're going to factor all denominators, make a list to get your LCD, multiply every term by LCD, all right? And then that will cancel the factors. Cancel the fractions. Cancel fractions, and then simplify and solve. Okay? Alright, so we're at homework, which means we are done. Happy homeworking, and I will see you next